Hello, everyone. My name is Himanshu Tyagi. I'm one of the co-founders of Sentient. Today, it's my great pleasure to be hosting this chat with Ed Felten, one of the founders of Arbitrum. But Ed, I'll start by embarrassing you a little bit. I think you probably... So I come from academic background. I'm a professor at a university, was on leave. Mm-hmm. But you are sort of an inspiration for people who are in academia and want to have a foot everywhere outside academia and are FOMO'd out of all that's going outside academia. I mean, your career path has been sort of an inspiration for a lot of people like that. So thank you very much for that. So we discussed, we'll go off script.
Yeah, okay.
So do you mind starting from there and telling us about your journey and how you've seen, even in crypto, how you've seen crypto evolve since you came into it, and what was your expectation at the beginning, and have there been any surprises?
Well, there have been really nothing but surprises. Yeah, so let me talk a little bit about my path. I spent many years as an academic. I taught at Princeton in computer science, and then later also in the public policy school, as I got interested in how technology affected things that are actually important to people. And back in, say, 20, 25 years ago, if I told people at a cocktail party I was interested in technology and public policy, nobody understood why those had anything to do with each other. And that's not the case anymore, obviously. I spent many years as an academic teaching and researching in areas around security and privacy and system design, which obviously sort of motivated eventually getting into the crypto space. I also have worked 3 times in the U.S. government, including as a senior advisor to the president and deputy CTO of the U.S. government. And that actually happened during the time that I was an academic working in the blockchain crypto space. So I initially got interested in this because it sort of, as an area, tickled a lot of my interests. It was around security, it was around privacy, it was around the interaction between technology and society and economics, it was around questions of law and borders and all of this. So I started maybe 2011 or 12 doing research academic research in blockchain stuff. And then in late 2013, I learned or heard about smart contracts, got super excited, right? This was like a 0 to 1 moment that was sort of like what happened when the web became became active and a way not just of showing people pages, but now a way of building applications and experiences. I could see that was going to happen for blockchain. That was super exciting, but it was also really obvious that scaling it was going to be a problem. So around 2014, early 2014, I started working on blockchain scaling. So worked on that for a while, went off to the White House for a couple of years, came back, and that's when sort of the drive to first build Arbitrum as a academic project, and then also finally to turn it into a commercial project, and that was 2018, and it's grown from there. I think if there's a through line to all of this, it is maybe 2 things. One is following my curiosity across a lot of different areas. And second is, like in hindsight, every 7 years or so, I seem to change career areas.
Right, so following your curiosity.
Yeah.
Okay, that one I think many people in this room can also relate to. I relate to that one. But you started with something very interesting. So you were, I know this, you were a deputy CTO for the US government.
Yeah.
I would put them in the sort of the regulatory side of things. And then you are now sort of at the heart of crypto.
Yes.
And regulators, I know a lot of things are changing in the US this year onwards, but regulators have a certain view of crypto. I am in some advisory committees in India, for example, and that's a very conservative crypto environment. Now that you have seen both these sides, any thoughts on that? Who is correct? Who is winning?
Well, I've been on both sides of that table. I've been the regulator, not only at the White House, not so much a regulator, but I also was at the Federal Trade Commission for a while. They're very much regulating industry practices. And I think having sat on both sides of that table, what really has struck me is that regulators have a really important role because they are protecting important values. when they're doing their jobs well, they're protecting end users, consumers against misbehavior. I mean, a lot of what we did when I was at the FTC was just try to shut down things that were out and out scams. And I appreciate now being, you know, in this other seat of trying to build a company and build a community and deal with users. I appreciate the value of having someone out there that's trying to shut down the scams and trying to make sure that the market can operate in a smooth way. When regulation is doing well, it sort of clears the field so that people who want to do business in an honest and positive some way can do that. And I think I may appreciate that more than some people in our space because I've been there on the other side and sort of recognize the extent of scams and bad behavior that really are out there.
Interesting. Yeah, so if regulators clear the scams and enable the rest of the technology, that's the space you are saying. That's right.
Absolutely right. That's right. So the other thing is that there are important roles for government as an enabler of good things happening. Some of that has to do with clearing away regulation that no longer makes sense. Some of that has to do with creating conditions for success. And that's things like making sure that we have the best education that we can have and that we don't do stupid things in our immigration laws to prevent the best talent from coming together and working together. So there's a lot that I think government can do as well to clear away barriers so that people who are smart and creative and are trying to create value are able to do that.
Great, great. So coming back to the topic of this.
Oh, yeah.
So tell us more about how you think about Arbitrum's mission now. So you started by saying the goal was to scale, I would say Ethereum, maybe scale blockchains, but Ethereum, let's say. And how do you see it now and what are the exciting things that you're doing now?
I mean, I've always tried to keep an eye on a very simple set of goals. That is, we want this technology to be as fast and cheap and reliable and easy to use as possible. And even when we're doing really sophisticated things, I'll be frustrated with the team if they can't explain why the thing they're doing is going to serve one of those goals. So I still think that we're trying to serve those goals. And, but the question is how, what is it sort of, you know, we're continuously pushing on things like cost and throughput. I think there's a bunch of really interesting areas now. One of the big ones right now is around interoperation, the ability of different chains, different activities, different kinds of models to work together and to have a smooth and continuous user experience across all of that. And you know, some of that is about thinking well about user experience and what it is that, you know, we want to present to users. What do users need to know? How do we make that work well? But some of it is also about doing stuff at the basic protocol level to enable the kinds of cross-chain functionalities that we want. Because just like we had to work and are still working for years to try to make, say, layer 2, layer 3 execution fast and smooth and trustless, I think we have a different flavor of that same problem now with cross-chain functionalities. And by the way, that extends also not just between sort of generic rollup chain A and generic rollup chain B. It also goes to interoperation, interaction with other kinds of models, whether it's privacy coprocessors, special purpose chains, or sort of more AI native kinds of models. I think figuring out how to make all these pieces work together, fit together naturally, without giving up the trust assumptions that we want to have is one of the biggest challenge areas we have now. And I'm really actually pretty encouraged with the progress we've been making as well as a community.
Okay, this last part that you said is exactly where I want to get to in this conversation next. So we started with, you guys started with one kind of compute, right? And that's the main thing to solve. Now, looks like suddenly the crypto is blockchains and crypto are generally interested in a wide variety of verifiable compute. Mm-hmm. And any thoughts on, you mentioned a few co-processors, any thoughts on what is this new landscape And what are you guys looking at right now? In that?
Yeah. I mean, we're looking at a few things. We're looking at, there's sort of one lane which is like general purpose verifiable computation. Something like a general purpose coprocessor so that you can have, say, attached to a general purpose chain, you can have some specialized functionality you're able to execute, you're able to prove more efficiently because you've done something, something clever. But then there are also methods that are specific to particular kinds of verifiable computations. And one of the obvious ones there is evaluation of an ML model, right? So you have a model and you have some commitment to the structure and weights of that model, say, and you want to be able to prove an evaluation of that model against some data in a very efficient way. And there's a bunch of interesting work going on, really focused on specializing to the structure of these models to be able to make them provable in a way that's much faster and cheaper than you could do with a sort of general purpose verifiable computation mechanism. So some really interesting stuff going on there as well.
What is different about AI model evaluation as a compute operation than others?
I mean, it kind of depends on sort of how you structure it. But if you think of sort of if you think of a pretty common type of model, you may have a large number of these units or neurons, right, which have each of which has a bunch of inputs coming in, and there's a very specialized computation that happens in that unit, right? It's typically you're taking a dot product between some vector of weights and some vector of inputs, and then you're taking the result of that, running it through some activation function, right? And particularly the fact that so much of the computation is around these kind of structured dot products, number one. And number two, that the topology, the connection topology of this thing is part of the model and something that you can optimize over. I think that's one of the characteristics of this as a problem. Another characteristic is just has to do with scale. Things like the number of inputs, right? Some of these models may take a volume of input that is larger than a lot of smart contracts do today. And so you might be sort of busting some of the limits that are kind of built into the standard, say, EVM execution model. And you need to think about how you can support just the volumes of data and the input sizes that you need for these. So we're really looking at sort of how you can specialize to these types of computations. And when you think about methods of proving, you can take either, say, optimistic proving or ZK proving, and try to specialize them to these sorts of problems. I think you can get to some really interesting places.
Right. So you mentioned large data and you mentioned some structured operations. When I think of verifiable AI compute, one thing which I find the most different about it is the non-determinism part of it. Yeah. The fact that it's inherently no two GPUs when using the same model will give you the same answer.
Right.
And so what does verifiable compute mean actually in that case?
Well, right. So this is a core problem, right? You have to think about what is in theory deterministic is in practice not deterministic. And there's a few ways around that, right? In any proving setting, it has to be the case that a particular outcome is provable or not provable, right? And so there's two ways of dealing with this. One of the ways to deal with it is to make the model deterministic, right? And at some fundamental level, you can say that the models are non-deterministic because the order of execution is non-deterministic, and that the kind of arithmetic you're doing is not commutative and associative in the way that sort of math textbook arithmetic is, right? And so if you want the model evaluation to be deterministic so that there's a single correct provable outcome, then you need to do something to make it deterministic. Maybe that means use a different type of data representation. Maybe that means that you make the order of evaluation deterministic rather than opportunistic as it often is in evaluation. But you need to do something about that problem. And that also is that's another issue that's distinctive to this model evaluation. Because almost all of the other computations that people would want to prove in this setting just have a single clear-cut answer. You don't have these low-order differences.
Right, right. So when you say that, because you mentioned some very specific recipe, so looks like what you're saying is we will come up with a very specific way of running AI models, which can be then verified.
Yeah.
I can't just verify how someone else is doing their AI computation.
I mean, one thing you can do is you can say, well, all we're going to require is the result someone produces is close, in some sense, to the result of the canonical provable execution. But that gets pretty tricky. I could say, right? I can tell by your expression you recognize why, right? It gets tricky, partly because it's not always easy to know what you mean by close or how much tolerance you should give, number one. And number two, if you let someone give an answer that is close but not identical to the sort of canonical one, this gives them some ability to put their thumb on the scale toward a result that they prefer a bit. And then you're going to worry about sort of fairness and manipulation issues. So that route also has its challenges.
Right. So exciting stuff ahead about verifiable AI compute. In the spirit of going off script,
Okay.
let me ask you something more about the ecosystem.
Yeah.
What are your takes on how do you feel Ethereum is going right now? And where do you see L2s? I mean, you are the OG L2 guy. So where do you see L2 in the future on Ethereum?
Sure. I mean, it feels right now like Ethereum is at an inflection point of some sort, and maybe multiple inflection points at the same time. I think people are too negative on Ethereum right now. I think there's a lot of unjustified negativism about Ethereum. Some of the things that people criticize Ethereum for are also strengths. People criticize Ethereum for being more careful about its evolution than some other ecosystems. But being careful and being stable and predictable and relatively safe makes sense for an ecosystem that has that much value, so many people, so many things developed on top of it. I mean, in terms of the role of L2s, I think Ethereum has and is in practice committed to the multi-layered approach. And I think the multi-layered approach has been spectacularly successful in the sense that it has increased the capacity of Ethereum by a huge amount. We're like, today, to first approximation, everything that happens on Ethereum happens on L2 and L3. L1, if you measure by gas or call data or other measures, is something like 2 or 3% of the total activity. That's not to say L1's not important, right? L1 is the foundation on which everything at L2 and L3 is built, and there's tremendous amounts of economic value there. And that's why most of the economics of the Ethereum stack flows through L1. But I mean, that's the reality that Ethereum is in. I think Ethereum had some luxury of not having intense competition it was facing for some time, and now it does, right? And when you face competition, it does push you to up your game. But I think that's a natural thing. And I think Ethereum is really resilient as an ecosystem. It is an inflection point, right? There are mistakes that can be made now, but I still think the robustness and flexibility of Ethereum is a huge asset. That's why I believe and our team believes that Ethereum is the right place for us to be.
Okay, perfect. And just the last question, what are your thoughts on AI as a vertical within crypto? What have you been seeing? What excites you? We spoke about some technical part of it, but more coming from project side, where do you see it going within crypto?
I mean, I think there's a few things. One is the power of AI in order to amplify the power of users. Right, the idea of an AI agent that is acting on my behalf, doing things for me on chain, not only from the standpoint of easing my experience, helping protect me from mistakes, but just being an active, always on participant in on-chain stuff on my behalf. I think that's really, really interesting and valuable. I also think that these chains, these ecosystems are incredibly complicated dynamical systems, and there's a lot of value from using AI to try to understand and control and manage the systems. The more I study and monitor the way that things like resource management and pricing are done in these ecosystems, the more I kind of wish for AGI to help us manage all of that. So I think there's actually a lot of value for AI in helping people like me who are mostly about protocols and infrastructure do our jobs better as well, not only for users.
I see. So personalized autonomous agents, and then the second sector you said is orchestration and all those kind of operations done by AI itself.
Yeah, that's right. Okay. Especially sort of on-chain resource management and configuration management. And then if I could add just one more. Sure. One of the areas where AI can be really helpful is to just to help people avoid making mistakes, right? Just to sort of look over my shoulder, see what I'm about to do or trying to do, and at the right time just say, hey, wait a minute, have you considered this? It looks like that number might be wrong. You've never talked to that address before. What's up with that? That's a great idea. Right, these systems are, one of the UX problems we have with blockchain is that the systems are very unforgiving of user mistakes, right? You cut and paste the wrong thing into the wrong box, and then you click sign, and now you've made a fatal mistake. And I think there's a lot we can do to try to protect users against human error.
Okay. On that note, we'll close this chat. Ed, thank you very much for answering my questions.
Thanks. It's been fun.